Rules of Differentiation, Part 2. So recall, differential calculus provides rules that allow us to study rates of changes or calculate these rates of changes of variables in an elegant, simple, and concise way. And these were the rules that we said that we needed to know. You don't have to memorize them though. We've got the constant rule, power rule, sum and differences rules, product and quotient rules, and the generalized power rule, which is just a subset of the chain rule. And we've already gone through the constant, power, and sum and differences rules. What we're going to go through in this part is the product and quotient rules and the generalized power rule. And I'm actually going to start with the generalized power rule first because this is what your text does. So the generalized power rule. In some instances, you're going to see a function of the form y is equal to f of x, which equals u of x to the n. For example, y equals x squared plus 30 to the 29th, or tax is a function of income, which equals this sort of inner function to the 3/2 plus 0.09y. So the generalized power rule is the following. The derivative of the function that has the form y is equal to u of x to the n is the product of the derivative of f with respect to u of x and the derivative of u with respect to x. We'll go through examples. Let's find the derivative of each of the following. Okay, so we're asked to find the derivative of each of these following functions using this generalized power rule. So the first thing I want to do is just write out that generalized power rule, and I'll just write it out right here. So all it's saying is that y is equal to some function. It's called an inner function. Some function of x, all to some exponent. This n is a constant. And what the generalized power rule tells us is that dy dx is equal to n times u of x times n minus 1. This looks kind of familiar, right? Just like the power rule. But then I'm going to multiply it by the derivative of this inner function, u prime x. So this is what the generalized power rule states. So if you're not used to this, if you haven't taken calculus before, what we're going to do is the same thing that we did when we went through the examples with the power function. We're going to start to define things to help us out. So what do I mean by that? Let's start with the first one. Y is equal to x plus 1 to the 29. So let's define what we know. Let's define our u of x. Our u of x is going to be this inner function, and it's x plus 1. Our u prime of x is just the derivative of this function with respect to x. And this happens to just be 1. And then my exponent, n, is going to be, in this case, 29. So now I can use this formula. Remember, these derivative rules, they're just formulas. So you figure out what each element is, and then you plug it in. So in this case, dy dx is going to equal n, which is 29, times that entire inner function. I'm going to put it in brackets, which is x plus 1 times, to the n minus 1, which is 29 minus 1, so that's 28. And then times the derivative of that inner function, which just happens to be 1, but I'm going to write it out here anyway. Okay, so notice, I'm going to make it really explicit for this first one. This is my n. This is my u of x. This is my n minus 1. And this is my u prime of x. Okay, so I'm just taking the derivative of u with respect to x. That's all that is. All right, so let's move on to the next ones. Let's move on to the second one. We're told y is equal to 2x plus 1 to the 29th. So this one's slightly different. Let's write everything out. What's our inner function? Our inner function is 2x plus 1 this time. I go right away and I say, what's u prime x? So the derivative of this with respect to x, here, you can write this out if it helps, du dx. It's just equal to 2. And my n is equal to 29. So I'm going to plug it into this formula to find my derivative. So I get dy dx is equal to n, which is 29, times the inner function, u of x, 2x plus 1, all to the exponent n minus 1, which turns out to be 28, and now times u prime of x, which is 2. It's 2 in this case. Okay? And you can keep it like this, or you can simplify it, multiply things out. I'm just going to keep it like this to save some time. Let's go to the third one. This one's a little bit trickier, right? So y equals 1 divided by x minus 1 to the 5th. So what I like to do whenever I have a variable in the denominator, I like to actually put it up on the numerator. So remember from the last lecture when we talked about power rules, a nice rule is that 1 over x to the n, is the same thing as x to the negative n. Okay, so what do I mean by this? Let's apply this rule to this function. I'm actually going to first rewrite this. This is how I like to do it. This is the same thing as x minus 1 to the negative 5th. That's the same thing as saying this. Just rules of exponents. Same thing. Okay? So now let's define everything. So my u of x, is this inner function, x minus 1. My u prime of x is just 1, right? The derivative of this with respect to x is 1. And my n is negative 5. It's negative 5. So I'm going to use this information. I'm going to plug it into my formula. I get dy dx is equal to negative 5, right? That's that n, times u of x, which is x minus 1, all to the negative 5 minus 1, which is negative 6, times 1. I'll write that out. You can keep it like this. We can simplify it. This is the same thing as negative 5 divided by x minus 1 to the 6th. Okay? And then finally, I'm going to go over here to do the fourth one to have a little bit more room. So this one's a little bit trickier. So we're not only going to use the generalized power rule, but we're also going to use the sum rule. So remember what the sum rule is that I've got these two functions of y. Here's the first element and here's the second element. So I'm going to add the derivatives of both of these up. So I'll show you what I mean. First I'm going to define my u of x here is going to be, this one's based on some study. I forget where it's from. So I don't know why I just brought that up. But anyway, it's going to be 0.61y plus 3,547. Okay? And I'm still putting u of x here. It's totally fine. This is what I like to do. Whoops. So then my u prime of x. I'm using different variables here. My variable here is y. So what I'm really looking for, if you want to be technical, is my u prime of y. Because there's no x in here. It's just y. So my u prime of y is going to be 0.6. And then my n is just 3/2. So let's figure this out, right? So really what we're doing is we're actually taking the derivative of tax with respect to y, which happens to be income. You weren't told that. So we're using different variables here instead of just lowercase x and lowercase y. But I'm going to use the sum rule. So the sum rule tells me that the derivative of this entire function with respect to y is going to be the derivative of this first guy plus the derivative of this second guy. So I'm going to use the generalized power rule to find the derivative of this first guy. Using this information, I come up with 3/2 times u of x, or u of y, 0.61y plus 3,547, all to the n minus 1, which is 3/2 minus 1, 1/2, times the derivative, u prime x or u prime y, times 0.61. Times 0.61. Okay, so that's this derivative for this guy right here. Got to use the sum rule now. I got to add in my 0.09. There we go. Quiz yourself. Find the derivative of each of the following functions. Pause the video and try this on your own. So If f of x is equal to negative 5x squared minus 10x all to the negative 3, then the derivative of f with respect to x is equal to negative 3 times that function to the negative fourth times the derivative of that inner function, which is negative 10x minus 10. If f of x is equal to negative 2 times x to the 10th plus 15th all to the fourth, then the derivative of f of x is equal to 4 times that inner function, negative 2x to the 10 plus 15 all to the third, times the derivative of that inner function, negative 20x to the 9th. And finally, if q of L is equal to L squared plus L all to the negative half, then q prime L is equal to negative half times that inner function L squared plus L all to the negative 1.5 times the derivative of that inner function, which is 2L plus 1. So in some instances, a function, y equals f of x, may be a product of two functions, u of x and v of x. In other words, y is equal to f of x, which equals u of x times v of x. When this is the case, we need the product rule. But for example, you may come across functions that look something like this. So you see that there's two separate functions here, x squared plus 30 times another function, x to the 5th minus 2x to the 3rd plus x to the 4th minus 10. And sometimes it's a lot easier to use what's called the product rule instead of multiplying this entire function out. Or for example, total revenue. Total revenue as a function of quantity is equal to 100 minus 3q times q. In words, the product rule says that the derivative of the product of two differentiable functions equals the first function times the derivative of the second plus the second function times the derivative of the first. So in math terms, if y is equal to f of x, which equals u of x times v of x, where u and v are functions, then dy dx equals u of x times v prime of x plus v of x times u prime of x. For example, let's find the derivative of each of the following functions using the product rule. Okay, so we're asked to find the derivative of each of the following functions using the product rule. So let's rewrite down what the product rule is. The product rule is that if we have a function that can basically be split up into the product of two functions, like this, x plus 1 times 2x, this kind of looks like two separate functions multiplied by each other, then instead of multiplying all this out, getting really messy, we can just use the product rule, which says that the derivative of y with respect to x is going to be, and I'm going to write in shorthand now. What that means is I'm not going to put the of x's in. The derivative of y with respect to x is going to be the first function times the derivative of the second function, so u times v prime, plus the second function times the derivative of the first function. So u times v prime plus v times u prime. Okay, so if you haven't taken calculus before, this is what I suggest you do. I suggest that you specify what the u of x is, the v of x is, what u prime is, and what v prime is. So here's what I mean. Here's the first one. Y is equal to x plus 1 times 2x. So the easiest thing to do, the best thing to do, is to specify stuff. So our u of x function, our first function here, is going to be x plus 1. And our second function is going to be this 2x. So now I can just take the derivative of each of these with respect to x. So the derivative of x plus 1 with respect to x is just 1. And the derivative of 2x is just equal to 2. Now the product rule says that we're going to multiply u of x times v prime of x, and then v of x times u prime of x. So in this case, dy dx is equal to x plus 1 times 2 plus 2x times 1. And you can leave it like that, or you can write it out. I'm just going to leave it like that to save some time. So let's move on to the second one. Y equals 2x plus 1 times 3x squared plus 10. So in this case, that first function is going to be 2x plus 1. The second function is going to be 3x squared plus 10. So then I know that u prime of x is equal to 2, and v prime of x is equal to 6x. I'm using the product rule here. So now, or the power rule. So then I'm just going to plug in what I know. I need everything. I have everything that I need to plug into this formula for the derivative. So dy dx is going to equal 2x plus 1, that's the u of x, times v prime x, which is 6x, plus the second function, 3x squared, plus 10 times 2. All right, so now I can move on to the third one. So the third one and the fourth one are a little bit trickier because they don't have x's and y's. So the third one gives us a total revenue function, 45 minus 1/5 q times q. And it's really simple. If you wanted to, you could. And I'm going to write this out actually, just to show you. What you've been doing is you can write this guy out as 45q minus 1/5 q squared. And you could take the derivative of this using the difference rule and using the power rule. And what you would come up with for tr prime, q is equal to 45 minus 2/5 q. Okay, so you could do that, but we're going to focus on the product rule, and we'll get the same exact answer using the product rule. So in this case, my first function is going to be this 45 minus 1/5 q. 45 minus 1/5 q. My second function is pretty simple. It's just q. So then I can calculate my u prime x. So the derivative of this function with respect to q, I know I'm using x here. If you want, you can put your q's in here. That's totally fine. Totally fine. So u prime q is going to be, in this case, negative 1/5. And v prime q is just 1. Right? The derivative of a variable is just 1. So then I'm going to plug in what I know. So my dy dx is really my dtr dq. So I'm taking the derivative of total revenue with respect to q. In this one, I was taking the derivative of y with respect to x. So anyway, my dtr dq is going to be 45 minus 1/5 q times 1 plus q times negative 1/5. And when I simplify that out, I get 45 minus 2/5 q, which is exactly what I got when I used the power rule. Okay, so now let's finally do this last one. Let me erase this so we have some room. All right. So for the last one, let's define our, this is profit, so profit is a function of q, so what we're really doing is we're taking the derivative of profit with respect to q. But I'm still going to write it out like this. I'm still going to say, what's my u of x here? What's my first function? Like I said, if you want, you can replace it with q. It doesn't matter. So the first function is 45 minus 1/5 q. The second function is the same thing, right? The second function here is just that q. So u prime x is equal to negative 1/5, and v prime is equal to 1. So it's the same exact thing as before. The only difference between these two functions is that with this guy, with the profit function, I'm actually going to use the difference rule as well. So it's a little bit longer function. I need to add in another rule. So what do we get? So we get d pi. So the derivative of profit with respect to quantity is going to equal the derivative of this guy minus the derivative of this guy. So we already know what the derivative of this is. We just calculated it when we calculated the derivative of this. So I'm just going to write it out. It's 45 minus 2/5 q. And then I've got to minus the derivative of this guy. So using the power rule, I just get 0.5 q to the negative 0.5. Quiz yourself. Find the derivative of each of the following functions. So pause the video and use the product rule. Try this on your own. So if y equals 2x times 4x to the fifth plus 10x, then the derivative of y with respect to x is 2x times 20x to the fourth plus 10 plus 4x to the fifth plus 10x times 2. If y is equal to x squared times x squared plus 30, then f prime x, so the derivative of y with respect to x, is equal to x squared times 2x plus x squared plus 30 times 2x. And then finally, total revenue, TR is a function of Q, equals 90 minus 1/3 Q times Q. Then the derivative, using the product rule, I've written this out in long form, the derivative of total revenue with respect to quantity is 90 minus 1/3 Q times 1 plus Q times negative 1/3. Now finally, the quotient rule. In some instances, a function y equals f of x may be the ratio of two functions u of x divided by v of x. For example, you may have y equals x squared plus 30 over x to the fifth minus 2x to the third plus x to the fourth minus 10. These are just random functions. Or average total cost, which isn't simplified, but average total cost is equal to 3q squared minus 12q plus 30 divided by q. So the quotient rule is probably the rule that you're going to have the most trouble with. Remember, you don't have to memorize this rule, so try to write it out in words, and I know that it's pretty long, but the quotient rule says that when a function f of x consists of two sub-functions divided by each other, the derivative f prime x consists of multiplying the negative of the numerator with the derivative of the denominator, plus the denominator times the derivative of the numerator, and then you divide all of that by the denominator squared. So in mathematical terms, if y is equal to f of x, which equals u of x divided by v of x, where u and v are both functions of x, then dy dx is equal to negative ux times v prime x plus vx times u prime x, and you divide that all by v of x squared. So again, I'm not asking you to memorize this stuff. Let's go through some examples. Let's find the derivatives of each of the following functions using the quotient rule. Okay, so we're asked to find the derivative of each of these functions using the quotient rule. I'm going to try to write the quotient rule up here. May not have a lot of space. So whenever we're given a function that's basically a ratio of two functions, it can be written like this. So u of x divided by v of x. Then dy dx, and I'm going to write in shorthand. I'm not going to put the of x's in here. The formula for the derivative of a function of this form is going to be negative times u times v prime plus v, it's a v, times u prime. I'll make my u's a little bit more curlier. And you divide all that by v squared. Okay, so what we need to do is we're going to need to define these u's, these v's, these v primes, and these u primes, and then plug them into this formula. So let's start with the first one. Y equals x plus 1 divided by 2x. So in this case, my numerator, my top function, my u is x plus 1. My bottom function, my denominator, is 2x. So my u prime x is equal to 1. And my v prime x is equal to 2. So I have everything I need to figure out what the derivative is. I'm just going to plug it into this formula to get dy dx is equal to negative times u. I'm going to put everything in parentheses, x plus 1. Actually, maybe you should do that just to get used to doing it. Whoops. Okay, so it's going to be negative times u times v prime, which is 2, plus v, which is 2x, plus u prime, which is 1, and then I'm going to divide this entire thing by the v function squared. I like to put that in brackets. Okay, that's it. You can leave it just like this. Let's move on to the second one. So for the second function, this one here, our u of x, our top guy, is 2x plus 1. Our v of x, our bottom guy, our denominator is 3x squared plus 10. Okay, so then I know that my u prime x, the derivative of this guy with respect to x is 2. And then my v prime x is a little bit more complicated. I'm going to have to use that power rule here. But the derivative of this function with respect to x is going to be 6x. Okay, so then I have everything I need. I'm just going to plug it into the formula. So dy dx is equal to negative times that u. I got to remember to do this. Okay, is equal to 2x plus 1 times v prime, which is 6x, plus v of x, which is 3x squared, plus 10, all times u prime of x, which is 2. And divide that whole thing by that v function squared. So here's this v function. I like to put it in brackets, and then I'm just going to square it. And you can leave it just like this. And finally, let's do this third one. So this one's a little bit trickier because it doesn't have y and x in it. It's got an ATC and a q in it. But what we're trying to figure out is the derivative of average total cost with respect to quantity, with respect to q. And I can simplify this guy out. You know, 10q squared divided by q is 10q. And things like that. But I'm not going to. I'm actually just going to keep it like this for now. So what we're trying to find is dATC dq. So let's define our functions. I'm just going to put u here. So our top function is 10q squared minus 2q plus 30. Our bottom function is just q. Our u prime, so the derivative of this guy with respect to the variable of interest with respect to q is going to be 20q minus 2. And then v prime here is just going to be the derivative of this guy with respect to q is just 1. So I got everything I need. I'm going to plug it into the formula. Oh, you can write dy dx. It's the same thing as saying dATC dq, right? This is the dependent variable. This is the dependent variable. This is our variable of interest. This is our variable of interest. So we can write this out as negative. Let me do my parentheses here. Write this down as negative. This guy, this whole guy right here, 10q squared minus 2q plus 30. I'm going to run out of room here. So I'm actually going to, so it's going to be this guy times v prime, which is 1. I'm not even going to put it in. Plus q times u prime, which is 20q minus 2. And divide all that guy by this whole thing by the square of this v function. And again, I like to put everything in brackets down here. Squared. So there's your answer, and this is totally acceptable. Quiz yourself. Find the derivative of each of the following functions. Pause the video and try this on your own. Okay, so if y equals 2x all divided by 4x to the fifth plus 10x, then this is what the derivative is going to come out to be. It's going to be negative times 2x times 20x to the fourth plus 10 plus 4x to the fifth plus 10x all times 2, and then we divide that entire thing by that v function squared. So 4x to the fifth plus 10x squared. If m of r is equal to 1 over r, then what we're trying to do is find the derivative of m with respect to r. I've written this out with all the steps, so we would get negative 1 times 1 plus r times 0 over r squared, which just simplifies to negative 1 over r squared. All right, so we can summarize the last 3 derivatives rules that we learned. The first one, the generalized power rule. Whenever you have a function of the form y equals f of x, which equals some function u of x to the n, where n is a constant and u is a function of x, then the derivative is n times that function to the n minus 1 times the derivative of that inner function. The product rule says that if a function is written as u of x times v of x, where u and v are both functions of x, then the derivative dy dx is u of x times v prime of x plus v of x times u prime of x. And then finally, the quotient rule. If we have a function that is of the form u of x divided by v of x, where u and v are both functions of x, then the derivative of y with respect to x is going to be negative, the negative of ux times v prime x plus v of x times u prime x all over v of x squared. Again, you don't have to memorize these functions. The best thing to do is to have these rules right out in front of you and then define what's my ux, what's the vx, what's u prime, and what's v prime x, and then plug it into the derivative formula.